Now we have a lecture on by our expert Dr. Shakeel Ahmed Mir. He is working as Associate Professor in Division of Soil Science. His title is The Influence of Protected Cultivation on Soil Characteristics. Let me invite Dr. Shakeel to give us an elaborative lecture on this protected cultivation and its effect on soil characteristics.
FAHEEMA. This is the topic. In my topic, I will briefly analyze and discuss the impact of protected cultivation on various soil characteristics. I will be highlighting the important these parameters only. So, in this presentation, I will also discuss the physical, chemical, and environmental properties as have been investigated in several studies in various parts of India. I think all of you know that what is protected cultivation. I need not explain it again. So we will explore and analyze how the protected cultivation affects various soil characteristics, as I said earlier. So let's understand what are the peculiarities of protected cultivation. Number one is environmental control. What we essentially do is we control the environment that is prevailing inside that greenhouse or polyhouse. And among the temperature factors, the most important is the temperature. What we do is that we control temperature. If it is cold outside, we have to raise the temperature to keep it within the feasible limits. So as a result of that, what we do is that we influence various soil characteristics. For example, the organic matter decomposition may be affected because of the temperature, because the microbial activity is enhanced due to higher temperature. Right? So raising the temperature also results in the release of the nutrients. Higher number of nutrients will be made available to plants. So then again, humidity is also controlled. Owing to change in the water availability to the plants, or when we make sure that we are applying the right quantity of water to the plants, the humidity is maintained. And of course, there are certain other facilities for controlling the humidity inside the polyhouses. Then light. Light will impact plant growth, and due to the influence of the plants or the plant roots on the soil, various soil characteristics may also be changed. And similarly, air quality is also controlled. We control what is the amount of oxygen, or what is the release of, or what is the level of the carbon dioxide within the polyhouse. That also influences the activity of the plants as well as the microbes. And the most important thing is the higher productivity. Our aim ultimately, there are two aims. One is to ensure that we are getting the high yields from protected structures. And number two is the off-season cultivation. Those are the two main purposes. What we do in a polyhouse is that we run an engine. I present here an analogy. What we do is that we run an engine at higher RPMs to give us higher output. This is what we do. We add lots of inputs, give it temperature, proper humidity. Ultimately, that will give us a higher crop yield per unit area. This is what we get. But what is different is that you cannot treat soil as a machine. It is not an engine or a machine. Soil is a living entity. You cannot treat it that. Of course, then there are certain limitations. And another peculiarity is the water use. Since we are ensuring that proper irrigation is given, and then it also has an influence on water efficiency. Right? So we ensure that the water supply is proper, and then we also ensure that the evapotranspiration losses are minimized, or these are controlled. And if we compare it with the open conditions, the runoff losses are totally evaded almost. Then we have input used for production. As I said earlier, that what we do is that we try to run an engine at higher RPMs to give us higher output. And this is what we do. We ensure, since the area concern is very small, the area under protected cultivation at a particular place is small as compared to the open field conditions. So we ensure that the organic manures are added, and every part of the soil it gets the organic manure, and also the fertilizer application is proper and in proper balance, and also with precision. And then an advantage is that we get higher nutrient use efficiency because the losses are prevented and the application is very precise and careful management of fertilization is there. So we get the higher nutrient use efficiency. And of course, by controlling the various environmental factors, what we ensure is that, and what we get actually is the higher nutrient use efficiency. The yield that we get from by using a particular amount of fertilizer is high. That is, the yield per kg of fertilizer applied or per kg of nutrient applied is high. That is why I say the nutrient use efficiency is high. And then another aspect which is directly not related to soil but has an indirect relation with this agriculture under these protected conditions, that is the assessing the life cycle, assessing the impact of the environmental impact of our production system. And this is what we do by making a life cycle assessment. If we life cycle assessment जब हम करते हैं, so we have to make sure that the environment or the carbon footprint is minimum. So लेकिन यहाँ पर अगर हम total analysis करें, जब हम life cycle assessment करते हैं, तो उसके लिए we use a term that is known as cradle to grave assessment. That what is the footprint of a particular production technology right from the raw material production to end of the life of the product. So if we go for even the partial assessment of this production system, we see that the cradle to gate impact जो है इस technology का, that is high because we need to provide interior heating. There is a cost involved in the material inputs and also the facility construction. Let us come straight away to physical properties. Bulk density, the mass of soil divided by the volume of the soil is measured in kgs per cubic meter or grams per cc. This property is important because it shows us what is the level of compaction of soil. But it also shows us is there a space or pore space available for the growth of plants and plant roots, as well as if there whether there is a proper room or the porosity for for water and for air. So bulk density has an inverse relationship with organic matter. As I said earlier, the organic matter that is added to the soil, or the addition of this organic matter is ensured. What happens is that it decreases when the organic matter increases. So actually, no limitations are posed to plant growth until the bulk density increases above 1.65 or above 1.7. Until that point, no restrictions are imposed on plant growth, but lower bulb density is always desirable. This is a study conducted by Shabaraman Sharma in 2018. This study pertains to Himachal Pradesh. At 5 locations, there was a comparison is made between a protected cultivation and the conventional cultivation. And as you can see, there is this marginal decrease in bulb density from year to year. This is a 2-year study, 2015 and 2016. So protected cultivation is compared with conventional cultivation, and you can see the mean values are decreasing at all the 5 sites. There is just decreasing under protected cultivation. Okay, you can see that it is higher in case of conventional cultivation and lower in case of protected cultivation. Then another property which is very important is the porosity, which is the ratio of the total pore space divided by the total volume that is occupied by pores, and divided by the volume total volume of the soil. This is also important for water transport and for aeration of plant roots, and also for the growth of microbes. Porosity also decreases under polyhouse conditions because of the presence of higher quantities of organic carbon. This is the data from the same study, protected and conventional cultivation, and this the porosity is higher, which is desirable in case of the soils, the 46% and 49% as compared to 47%. And you can see at all the 5 sites, in under protected cultivation, porosity is higher. Another important physical property is water holding capacity. What is the amount of water that is held by soil? Usually we express it as percentage. So water holding capacity, it is also higher under protected cultivation. This is based on a 2-year study. ये मैं 2 साल के study की बात कर रहा हूँ. तो यहाँ पे भी water holding capacity because of जो है improved bulb density and because of addition of organic matter, and also because of the improved porosity, water holding capacity actually increases under protected conditions. So data pertains to the same study. This is the mean water holding capacity under protected conditions, and this is under conventional cultivation conditions. This is, you can see that there is an improvement, a marginal improvement though, but the water holding capacity is also higher. A soil structure, as we know, is what is the status of aggregation in the soil. कैसे soil में primary or secondary particles, how they clump together or how they are cemented together to create soil aggregates. And formation of soil aggregates is desirable because it creates better conditions for microbial growth and also for transportation of water and nutrients. This is a condition where there are soil aggregates. These are soil aggregates. These particles in brown color are soil aggregates, and this is a well-structured soil. What happens is that there is always a space between the soil aggregates, and that those spaces actually they make room for plant roots, for air, and also for the transportation of water. If you look at it closely at one aggregate, if you look at it closely and see, this is the enlarged view of this particular aggregate, and you can see what is there. Its organic matter is there, the soil particles are there, or there is soil particles are there, the decomposing organic matter is there, and also we have nutrients. What is not shown here is there may also be presence of certain microbes and fungal hyphae. They may also be present here in the aggregates. So this is a desirable property. How we assess the soil structure is there is a physical quantity that is known as mean weight diameter. This is the mean weight diameter. Higher mean weight diameter is desirable in soil. The bigger bigger aggregates are desirable. We always want our soil aggregates to be bigger in size and also to be water stable. If it is water stable, that means the aggregates cannot be broken easily by erosion or by rainwater. तो ये हम देखेंगे कि mean weight diameter जो है that also improves under protected conditions. So soil structure also has a positive influence. So remind that please remember that this is a 2-year study. ये कोई long term study नहीं है. Let us sum up what are the number of nutrients that are required for plant growth. So I have compared this with the nitrogen. Okay, for every 100 grams of nitrogen, we may actually require this much of phosphorus and potassium, sulfur, magnesium and calcium. Similarly, these are the micronutrients that are required in proportion to the nitrogen. See that the micronutrients and macronutrients all are very important. And number one, the foremost factor which is of foremost importance is the soil organic matter. Let us see what happens to soil organic matter. This is the percentage of soil organic matter and the different cultivation modes or cultivation practices, which is polytunnel, polyhouse and open field. And what we see is that around open field, in the open field conditions, the organic matter is lowest, and because of the careful management, what happens is the organic matter may actually increase, and it has gone up to around 5% under these protected conditions. So organic matter, due to more careful management and addition of higher number of organic matter or manures, the soil organic matter increases. And then let's come to nitrogen. This is the 0.15% total nitrogen. This is the total nitrogen. These are the values for total nitrogen. So I am comparing here the open field conditions with the polytunnel. All right. These are the two different modes of protected cultivation. 0.15% total nitrogen is a typical figure for open field soils. So it is 0.15%, and with the polyhouse practices, it has improved to 0.18% and 0.25%. So obviously the nitrogen is also increasing. So this is available phosphorus under open field conditions. It is also increased. This is for few years of this is the condition where the cultivation has been practiced for 2 years, around 2 or 3 years. So within 2-3 years, we see that the values are increasing for phosphorus also. And then potassium. This is available potassium. So similarly, the graph is more or less similar for all the nutrients, including soil organic matter. This is soil pH. So it is low in case of the open field conditions, and then it has raised and reached up to neutrality 6.9. All right. So you can have a reasonable control on pH because the management is careful and the precision is important. You can actually check and improve the soil pH conditions very quickly and the polyhouse conditions. And because of the careful, as I said earlier, the higher amount of organic matter, we ensure that the organic carbon in the soil is high. That is what it has implications on the soil pH also. The pH has come to neutrality. Let us see a list of properties. What is happening when we compare open field cultivation with continuous protected cultivation? Okay? Different durations are given there. So the number one is the cucumber is grown in the open field for 1 year and see pH 6.2. All right. So let us see check the pH first. And cucumber 1 year and open field conditions, and the same cucumber for 3 years, the pH has declined. And cucumber for 7 years, continuous protected cultivation, that is 6.003. If this is what happens after 7 years, It has declined as in 3 years. It has declined by just by 0.11%. But here, in case of cucumber, it has declined. In case of 7 years of cultivation, it has declined to a value of 6.023. This is why the overall picture, after certain years of a long duration, the picture may actually change comprehensively. This is what has to be taken care of under protected cultivation. And if we, now that was the sole cucumber as a sole crop, then if they have, for experimental purposes, what they have done is that they have mixed or they have rotated cucumber with wheat for 15 years, and see a simple rotation by a graminaceous plant has brought the pH to neutrality. It was 6.92 and 6.85, and this is what a simple mixing can do to your pH, and this is how the properties may improve by mixing the crops. EC is not of much importance. So organic carbon, you can see this is organic carbon has improved. Here in case of cucumber and tomato, where we have used it for 21 years, this is a 21-year rotation. Under protected cultivation, the organic carbon has kept on increasing up to 21 years. This is the positive influence of rotation even within the protected conditions. बाकी properties में आप देख सकते हैं, you can see the total nitrogen has improved. So simple rotation is also important under protected conditions. This is what this data conveys. Another fact is the microbial biomass carbon. Microbial biomass carbon actually gives us the what is the microbial load in the soil, or actually what is the microbial activity indirectly, what is the microbial activity in the soil. So microbial biomass carbon is at 3 locations. At all the 3 locations, it has increased because of the organic matter, better growing conditions for plants, better activities for microbes. The microbial biomass carbon has improved. So more microbiases, MBC under polyhouse conditions is attributed to organic carbon, which provides more substrate to microbes. Then another important parameter, that is the soil enzymes. You know that soil, there are 2 types of enzymes: the soil constituting enzymes and then inducible enzymes. Or there, we may say there is another way of looking at it. We may have enzymes which are present inside the plant, living cells in the soil, and then there are enzymes which are extracellular enzymes, which are present inside the microbial bodies, outside the microbial bodies and outside the plant roots also. They may be present in the soil per se. वो soil में present होते हैं. They also can carry out their activities. So soil जो enzyme activity होती है, that it is an important indicator of soil pollution and soil quality. अगर soil quality decline हो रही है, it will be first जो उसका indication दे सकता है हमें, that will be soil enzymes. This is the first जो है easily जो है हमको short term में और even long term में भी हमारी soil पे क्या impact पड़ रहा है, soil enzymes are important indicators. तो हमने जी इसमें enzymes दिए, there are 6 classes of enzymes are there, and in soils all enzymes belonging to all the 6 classes of enzymes are present there. Those enzymes may be oxidoreductases, transferases, okay, hydrolases, ligases, lysates. So we have all the 6 types of enzymes, and among the, I have discussed here the few important enzymes, and one of the enzymes is dehydrogenase enzyme that is involved in dehydrogenase की इसकी peculiarity ये है, it is always present inside the living cells. So dehydrogenase हमको is important. It is a hydrolase. ये जो है oxidation करता है. So it is important for organic matter oxidation as well as for nutrient cycling. So this is the first impact जो हमको दिखाएगा, that will be a dehydrogenase enzyme. It is an important indicator of soil pollution or soil stress अगर होगा, and also it is used as an indicator of soil quality and soil health. And see, this is totally in contrary to what we have seen so far. We saw that organic matter is increasing, the nutrients are increasing, cation exchange capacity increases, water holding capacity, valve density, all of these parameters are actually getting better under protected conditions. But what is happening here that if we compare the summer and winter activity of enzymes under these polyhouse conditions, what is polyhouse conditions and open field conditions, what is there that under open fields, this is the activity, this is under summer, right? Under summer the activity is like this, it is higher, then right up to 3 to 5 years, then from 5 years onwards it is declined to 6 to 8 years and 10 years. From 10 years से आगे जब हम जाएंगे, you can see the dehydrogenous activity is actually increasing, and then this is, and for winter the same, the overall activity in winter will be low, but even in winter it goes on decreasing and decreases further in beyond 10 years. So enzyme activity, dehydrogenous activity actually decreases. This is actually in contrast to what we have seen so far. And another enzyme is the phosphatase. You know the phosphorus sources in the soil, that capacity actually declines. Although इससे पहले हमने देखा, what we saw earlier was that microbial biomass carbon kept on increasing with protected cultivation. So there is something to read between the lines. And what is that? I'll tell you later. This is also another enzyme that is FDH. Yeah, fluorosylene diacetate hydrolase. This enzyme is also used as an indicator, soil quality indicator. It is also declining. It is following the same pattern. It decreases both in summer as well as in winter. So there is something that is missing here, is that most of the studies that have been conducted for analyzing the influence of this protected cultivation on soil characteristics, in shorter duration we see that all of the parameters are improving because of the careful management practices. But there are, you see, as I said, you see what happens to microbial biomass here. मैंने इससे पहले आपको बताया कि माइक्रोबियल बायोमास कार्बन जो है दैट इंक्रीजेस. माइक्रोबियल बायोमास कार्बन मींस द population of microbes in the soil is increasing, all right? So, but the enzyme activity, what it indicates that soil, the level of stress in the soil or the pollutions in the soil, it is actually increasing after 5 or 7 years. It keeps on declining. So what is to understand here is that the microbes that are developing in the soil may not be the microbes which are favorable to plant growth. Those may be pathogens, और वो हम अपने इस एंजाइम एनालिसिस से या फिर माइक्रोबियल बायोमास कार्बन के एनालिसिस से we cannot discriminate between the two kinds of microbes. You understand? So that is why what needs to be monitored is the overall, what is the influence of the protected cultivation on soil quality. Thank you very much.
सॉइल फर्टिलिटी है, ये काफ़ी टेक्निकल है हमारे. सिंपल टर्म जो सॉइल फर्टिलिटी है दैट इज डिक्रीजिंग इन ओपन फील्ड्स आल्सो. उसी परसेंटेज से वो प्रोटेक्टिव कल्टीवेशन में भी सॉइल की फर्टिलिटी डिक्रीज होती है. अगर दो क्वेश्चन
नहीं कोई नहीं इशू है, जस्ट
वो तो कैसे हम मैनेजमेंट कर रहे हैं, मैनेजमेंट कैसे हम कर रहे हैं. प्रोटेक्टिव कल्टीवेशन में एक चीज़ है कि एरिया इज़ वेरी स्मॉल, तो हमारा इन्वेस्टमेंट उसमें बहुत होता है. तो उसमें सॉइल का मैनेजमेंट है दैट इज़ ईजी, क्योंकि छोटा सा एरिया उसमें हमको फर्टिलाइजर पता है. अगर 10 बार भी एप्लीकेशन करना पड़ेगा कोई प्रॉब्लम नहीं है.
फर्टिलाइजर कितना सॉइल
हाँ नहीं, हम लोग कर सकते हैं, मतलब वी कैन मॉनिटर इट एंड वी कैन मॉनिटर इट एंड वी कैन मेक द एडजस्टमेंट वेरी क्विकली, क्योंकि एरिया भी छोटा है. इसलिए फॉर 20 ईयर्स जो है जो एनहांस होती रहती है जब तक कि सॉइल को जो है सॉइल की डेफिशिएंसी लेवल जो है वो क्रॉस हो जाती हैं, ऑप्टिमल कंडीशंस बनती हैं, देन द फर्टिलिटी कैन कीप ऑन इंक्रीजिंग.
यूजेज से नो डाउट फर्टिलिटी का काम होती होगी.
हाँ.
लेकिन होती है। हमारे यहाँ ओपन फील्ड्स में हमारी जो फार्मर्स कहते हैं कि जो ओपन फील्ड में हमारे को एक एडवांटेज है, जब बर्फ गिरती है, हमने तो उसको खराब किया अपने सॉइल को पूरे साल, लेकिन जब बर्फ गिरती है तो उसके बाद एकदम से वो एकदम फर्टाइल हो जाती है। वो चीज़ तो हम प्रोटेक्टिव में नहीं कर सकते।
ओपन फील्ड कंडीशन was you must cultivation practice tillage करा tillage किती करा होतो दोन क्रॉपिंग किती करा होतो tillage या काफी tillage right from plowing tillage practice वो बहुत कम है चला ओपन कंडीशन में कंपेयर करो उस प्रोटेक्टेड कंडीशन से यहाँ पे tillage practice बहुत ज़्यादा होती है क्योंकि हम लोग we cannot keep the land vacant वो हमारे लिए एक्सपेंसिव है so energy requirement जो inside पॉली हाउसेस की होती है बहुत ज़्यादा होती है और tillage की वारिया ज़्यादा है उस वजह से जो अभी मैंने हम बता दें कि ऑर्गेनिक मैटर इंक्रीज हो रहा है लेकिन उसका डिकम्पोजिशन भी फास्ट हो रहा है। अब ये बैलेंस कैसा हो रहा है अगर हम ऑर्गेनिक मैटर एडिशन नहीं करेंगे पॉली हाउस में बिल्कुल ऐसे खाली एनवायरमेंटल कंडीशंस ही कंट्रोल करेंगे वी में एक्चुअली लूज ऑर्गेनिक कार्बन एट अ मैसिव रेट क्योंकि टेम्परेचर बहुत हाई हो रहा है और मॉइस्चर भी हो रहा है माइक्रोब्स की डिकम्पोज की एक्टिविटी जो है वो एनहांस हो रही है। अगर हम ऐड नहीं करेंगे वी में एक्चुअली लूज एट 4 or 5 times दिस ऑर्गेनिक कार्बन फ्रॉम सॉइल। अब यही है मसला कि हमसे हमारा मैनेजमेंट जो है उसको एडजस्ट कर रहा है लेकिन देयर आर सर्टेन फीचर्स व्हिच इवन द मैनेजमेंट कैन नॉट क्योर वो है जब हम पैथोजेंस जो है हमारी जो है ये एक हाई एनर्जी इनपुट प्रोडक्शन सिस्टम बन जाता है वी हैव टू गिव कीप ऑन इंक्रीजिंग द हाई इनपुट फॉर एग्जांपल अगर ऑर्गेनिक मैटर या माइक्रो न्यूट्रिएंट हम ऐड नहीं कर रहे हैं तो माइक्रो न्यूट्रिएंट की डेफिशिएंसी तो आएगी क्योंकि नाइट्रोजन फास्फोरस पोटेशियम तो हम डाल रहे हैं उसमें नाइट्रोजन की डेफिशिएंसी तो आ ही जाएगी 100% आ जाएगी। फर्टिलाइजर्स आ रहे हैं तो पीएच का एडजस्टमेंट तो करना ही पड़ेगा सो एज द ईयर्स पास ऑन द डिपेंडेंस ऑन एक्सटर्नल इनपुट्स विल इंक्रीज वो तो हमेशा ही होगा। सो जो सॉइल का स्ट्रक्चर जो सॉइल एग्रीगेशन पहले के ईयर्स में बढ़ गया था जो रिपीटेड टिलेज की वजह से वो स्ट्रक्चर भी अल्टीमेटली
वो ग्राफ का बिल्कुल नीचे आएगा।
हाँ वो दैट विल कीप ऑन डिक्लाइन।
वो कब तक है मान लीजिए
हाँ लाइफ नहीं हम कह सकते हैं कि फिर हमको ये हाई हमको इनपुट्स जो देना इट विल बिकम मोर इनपुट इंटेंसिव हमको और ज़्यादा हमको इनपुट्स देने पड़ेंगे ज़्यादा मेंटेन तो कर सकते हैं लेकिन हमको इनपुट्स बढ़ाने पड़ेंगे पॉली हाउस में तो ऐसा है कि आप अगर पॉली हाउस से मिल्क ऊपर वाला लेयर निकाल के दूसरा भी लगा सकते हो दैट इज ऑल्सो पॉसिबल वो छोटी जगह है मैनेजमेंट इज ईजी।
तो आजकल जो डिफरेंट मीडिया वगैरह आते हैं ना यूजुअली तो हम वही हाईटेक पॉली हाउसेस बोलते हैं तो ऑब्वियसली उनको हम चेंज वगैरह भी करते हैं
अदर दिखाएं कुछ बायोलॉजिकल दिखा रहे हैं नाउ दी पैथोजेंस का जो है जो पॉपुलेशन है और मैम को पता भी होगा वो पॉली हाउस कंडीशन में अगर डिजीज कंट्रोल इज वेरी इंपॉर्टेंट ईजी भी है लेकिन करना भी ज़रूरी है और उसके लिए फ्यूमिगेशन वगैरह जो स्टेरिलाइजेशन की टेक्निक्स जो है मीडिया की स्टेरिलाइजेशन टेक्निक्स हैं वो करना ज़रूरी होता है बिकॉज फेवरेबल माइक्रोब्स भी ग्रो होते हैं उसके साथ में जो पैथोजेंस वगैरह हैं जो अनफेवरेबल होते हैं उनका ग्रोथ भी तो उतना ही एनहांस होगा ना अगर सॉइल माइक्रोब्स का ग्रोथ एनहांस हो रहा है जो हमारे डिकम्पोजर्स हैं या फिर जो फिजिबल माइक्रोब्स हैं उनका अगर ग्रोथ एनहांस हो रहा है साथ साथ में पैथोजेंस के लिए भी तो अच्छी कंडीशंस बन रहे हैं सो दैट हैज़ टू बी कंट्रोल्ड।
और सर जो जैसे यूजुअली हम अंडर ओपन कंडीशन में सॉलिड फर्टिलाइजर्स यूरिया डीएपी वहाँ पे यूजुअली ड्रिपर्स ड्रिप इरिगेशन ये जो फर्टिलाइजर्स लिक्विड फर्टिलाइजर्स मिक्सचर्स इसके बारे में थोड़ा
हमारा ज़्यादा इस पर ड्रिप इरिगेशन पर है लोग प्रोडक्ट कंडीशन में ज़्यादा जो है सॉइल साइंटिस्ट की ज़्यादा वो डिपेंडेंट नहीं होते हैं सॉइल साइंटिस्ट को पता होता है एरिया छोटा है तो उसमें है तो मतलब न्यूट्रिएंट्स तो वही हैं न्यूट्रिएंट्स तो जो
एनपीके देना ही देना होता है
वो तो देना आप किसी भी फॉर्म में दोगे किसी भी फॉर्म में देंगे आप न्यूमेरिकल फॉर्म में देंगे नाइट्रिक फॉर्म में देंगे वो तो ऑब्वियसली देना ही पड़ेगा आपको। तो उसमें प्लांट के लिए जो प्लांट तो पॉली हाउस कंडीशंस में उसी आयन को एब्जॉर्ब करेगा उसी स्टेज में करेगा एब्जॉर्ब जो बाहर करेगा लेकिन उसकी फिजियोलॉजी इनॉर्टी वगैरह तो सेम ही वो चेंज नहीं होती है। आप किसी भी फॉर्म में फर्टिलाइजर दीजिए लेकिन जो फॉर एग्जाम्पल अगर यूरिया हम ज़्यादा करेंगे वो किसी भी फॉर्म में करेंगे तो उसमें एसिडिटी तो क्रिएट करेगा ही क्रिएट तो वो माइक्रोन्यूट्रिएंट डेफिशिएंसी उसकी वजह से अगर पीएच बैलेंसिंग जो है वो खराब हो गया तो माइक्रोन्यूट्रिएंट्स की डेफिशिएंसी जो है वो आ सकती है। बाकी मीडिया हो या सॉइल हो, ये जो एक रिलेटिव रेशियो होता है न्यूट्रिएंट्स का वो मेंटेन करना इम्पोर्टेंट है।
Thank Dr. Shakeel for his presentation.